All right. So we're talking about the Swift language, and some of the topic and is interesting. It's normally for most of the computer language we're using, right? And the first one is string operations. Okay, and I think lots of the languages is going to dealing with the strings. Okay, and all has a bunch of the string functionalities, and which is very similar. Okay, Swift has a very nice one. Okay, let's say, okay, starting here, okay, and most of the time when I talk about the pages, right? Page 115, and when you actually define a string, you can use same thing using let, okay, and variable, right? So I think should everybody know let should be constant, and the variable is a changeable or commutable. Now this function is very useful. I think when you actually trying to, okay, this one here, triple double quote. It has a 3 double quote here. Okay, what does this do? Okay, well, you actually is going to define the format for multiple lines. Okay, multiple lines. So you're going to using triple double quote beginning at the beginning and your triple double quote in the end. And there's a little trick here if you want to play around with these triple ones, right? So let's go to the playground. I'm sorry, this one is. Can you see? Oh yeah, you can see my screen. Okay, so when you do actually the triple code here, okay, and it's okay if you guys can see here. Okay, let's joke here. Let's joke here. You have a triple double quote here, right? And you actually can add as many lines as you want. Brandon, what do you talk?
What is it?
Are you talking? I see your phone is on. I mean the.
Oh, I'm sorry. My I had to unplug and plug my mic back in.
Okay, that's fine. All right. So when you actually add more, okay, I gotta use that. Add more lines after this one and before the triple one here, and this one still work. Okay, they are going to delete all the black spaces, okay, white spaces before and after, before the end of the triple double quote and after triple quote, right? And also interesting, if you want, if you understand, if you add a white space before the last one, it's going to give you a warning here. Okay, it's not. Hold on. Oh, this one. Okay. Wait a second. Is my running? Hold on. Yeah. This is online Swift. The playground, and I think I talked the last class, right? So when you actually add this, that's what I play around here. Okay. If you add, okay, different things, it's going to indicate, okay, insufficient indentation of line in multiple line string with a Q. You have to put, because we actually add a one space before the second line, okay, you actually can have to add a question one with the same one. Oh no, I'm sorry, should have using the same line, okay, because before this triple line I have added 3 space. So all the line have to add 3 space before that, and then they are going to have a follow with a format with that one. Okay, now it works. They're going to delete everything, which means, okay, the last 3 double quote and whatever the white space you have in front of it, and all the line have to have a 3 space here, 3 space here, and 3 space here. Okay, so this is actually for the formatting purpose, because you are going to use this triple double quote to format the line, right? Whatever the format is, so they can use in this kind of format the last 3 triple quote to make sure they aligned with all your line here with this kind of format, because they only accept this kind of line command. Okay, line command, right? And all the space here is no use, so I'm going to delete this space here and also delete this space here. Okay, all the space between this one you can add whatever you want. Okay, but this format you have to follow, which means the beginning of this each line should be like the beginning of the last triple double quote.
So is there no version of like doing \n or \t in this?
Oh yes, okay. Oh, who is this? Okay,
Me, Nicholas.
okay. Yes, okay. Later on, we have lots of things. Okay, and with this escape here, escape character. Okay, we'll talk this later. Okay, Nicholas. So.
Oh, it has to be \r because we're on Mac. Okay.
Oh, you're in the
that
Mac.
keeps tripping me up.
Okay. Okay. Right. So this is a triple double quote. This is a new feature. Okay, which basically lots of the especially lots of the new program is going to how to format your string here, and this one is going to using the multiplying the string, very new feature. Okay, nobody have this kind of feature before, and not nobody. Okay, this is very new feature for Swift with a triple double quote. Okay, and also we're going to using so-called escape, like Nicola said, right? For example, this is a string here. Okay, we're going to say you trying to put something, okay, inside. What do I say? Okay, you trying to put a double quote inside of double quote, because when you actually print out this string, okay, you want this double quote, put it inside of this whole strings, right? So if you want to put double quote, you cannot directly put the double quote, right? And the compiler is going to complain, oh, okay, what do you mean so many double quote? So let's say you want to put hello world when this string output a double inside a double quote, okay, and then outside you have a double quote here, right? All the string have to put inside the double quote, okay, and you are going to using / double quote, okay, / double quote, okay, to here, which means, okay, when this actually string print out later, you are going to see a clear double quote quoted hello world here. Okay, it's the same thing for lots of the specific characters, right? / double quote, / single quote, // what is / means? Means you want to put the / inside the string, okay, because / is very special, okay, and the / t, okay, it's a tag, put a one tag in the string, okay, / r, we got a new return, okay, beginning to the next line. And so these are the most of the language has same, okay, even the Java side do the same thing, okay, like this, using the / so-called escape, and put in the strings. And empty string, okay, actually you can sign a empty string using double quote, okay, there's no space in the double quote. If you say space in double quote, there's space, right? In this case, you immediately say double quote, okay, like this, right? And then actually there is a property, okay, can check its string is empty or not. You can see here, my string dot is empty, okay. You see here, how do you know this is a property, not a function? Because every time when you call the function, you have to use parentheses in the end, right? So obviously we don't have a parenthesis in the end. So this is so-called a property of this string, okay? This string actually can detect, okay? This property actually can detect if this string is empty or not, right? So you define my string is empty here, and then you are going to call this property, okay? Be careful here, I is a lowercase, and the E is the uppercase. This is we call it camel. This is kind of thing called a language camel format, right? Make this like two English words, right? Is one word, empty another word. So you using E is a capital to separate is and empty. These are two words you can see clearly, right? First thing. Second, this is actually is a property, okay? Because you know there's no parenthesis in the end. If you see a parenthesis, that is a function. If you do not, that's a property. This property actually recorded is my string is empty or not, right? So in this case, you can see this empty. So this actually is empty variable actually is a Boolean type. So this one, because my string is empty, so this is embedded variable should be true. Okay, when this one is true, they're going to print out the string is empty. Right. Okay, so this is a empty one. Okay, and then we are going to have a two types. It's a little confusing. Whenever using double quote and put it anything inside of double quote, okay, even only one character, still is a string type. So whatever you're going to put in the double quote, it's a string type. Okay, and I think it's a little confused which language. Okay, there's one language. Okay, I totally forgot which one. If you're using double quote, okay, everything inside of double quote is a string. Then if you want to put a one character using single quote, okay, that is a character type, right? And also in the Java, is this in Java? Yeah, I'm going to figure out. In the Java, the JavaScript, okay, actually using the double quote and single quote are the same. Okay, both either using double quote or single quote, it's a string. Okay, whatever you put in a single quote or double quote, okay, there's a string. But okay, that's a Swift here. For the Swift, there's no single quote. Okay, so there's no single quote. Okay, this is just a description here, right? If I'm going to show you, I was surprised, okay, because the very popular one like the JavaScript, and they use both single quote, double quote. Okay, but for the Swift, there's no single quote. Okay, let's say if I'm going to put a be careful here. I'm going to do many things just to see what I have here, right? So let's say let a equal a, right? You can see this line here, this one here, right? And it looks no problem, right? What if I change this double quote to a single quote?
It'll change the type that A is inferred to be.
Yes, okay, this is very nice compiler. Okay, basically say, look, okay, single quote string literally found, you should use in double quote instead. Okay, so you cannot use a single quote, which means in the Swift syntax, there's no single quote. You have to put in a double quote. Now, also in the double quote, okay, they consider this A is a string, not a character. So you have to explicitly define this B, like let B colon character, this is type, right, equal B, and then this variable B is becoming a character. And also say if you sign it wrong, right, BC, okay, BCC, okay, and then it's going to be complained, right? B is should say character. I deleted my comment to see what the compiler says, right? Because compiler says cannot convert value of type string to specify type character. BCCC actually is a real string. It's trying to convert it to the character. No way, because they have 4 characters here. You only can define one character, right? So only way to doing it is you have to only have a 1 character because it's a character type, right? And this one, whatever you put, okay, 1 character, 2 character, whatever character you put it in for in double quote, didn't specify the type, it's automatically declared as a string. Okay, string. So this one, anything you put inside of double quote, it's a string type. Okay, if you want to do a character type, you have to explicitly define it. Okay, so now also concatenation. Okay, that's most of the computer language you do, right? You can using add 2 strings together. typically here hello, comma world. You can add string 1 and string 2 together. You got these two. And also you can use a variable here. Variable string type you can add. Okay, in this case, using my string to add it together, right? And then you're going to using plus equal. Okay, and let's go with Brandon. Is this what is the plus equal means? Brandon.
Can you hear me?
Yes. What is the plus equal means?
That means it's gonna add it to the string when it prints out.
Okay, you see the line here, right? My string plus equal hello here. Okay, what is this? Can you explain what is exactly explained to plus equal what? For example, my string. Can you extend it this expression here?
So I guess the best way I can explain it, if it makes sense, is that it's taking what you have as the variable myString, and it's either adding or modifying the string with what you're putting after the plus equal sign.
Okay, so can you directly tell me what is equal? Okay, what is it?
I'm sorry. So that would equal. Let me just look. So that should equal hello world hello.
Okay, and it should be like this. Okay, actually, my string should be equal my string plus hello, right? Okay, so I know you understand here, right? So let's say my string here. Okay, this one should be the same as my string equal plus, okay, this hello, right? So actually this is one. Basically you are going to repeat this variable again here in the right hand side of equal and the plus the rest. This is what this plus equal means, right? Plus equal means. Okay. Right. So this is one you can using this plus and the plus equal to concatenate, okay, all the strings, okay, like most of the other languages. Okay. All right. Now, okay, we're going to introduce a new syntax. Okay. Sometimes you want to using double quote to put all your strings within the double quote, but some kind of places I want to reference to a value, okay, variables, right? So let's say I have a name, Rick, age 30. These are the two variables. Name is a string, okay, age is integer here. So these two variables I want to reference in the double quote. This is very useful and very often used. You're going to using backslash and then the parentheses. Inside of the parentheses could be all kind of variables, even a function calls, or even a expressions, okay, of the variable, something like that, right? So basically, when you see backslash inside the double quote, you're going to see the backslash parentheses. Okay, inside of this parentheses, let me repeat again, could be variable. Okay, could be string variable or whatever, double variable, integer variable, could be a function call. Okay, could be a expression of your variable, right? Two variable added together, something like that. You could expression variable. So these basically, this one you can introduce your variable here, okay, and then the whole string is going to print it out. Okay, so here's the typical one. Rick, name is Rick, age is 30. You can see backslash name. So when you print out this string, you're going to see Rick replaced this backslash name variable. Okay, so Rick is backslash age actually is this age number here. Okay, actually this age is going to convert from integer two string, okay, and then years old. So you are going to see Rick is 30 years old. Okay, this is output, right? So it's this kind of things give you a very flexible, okay, to insert your variable, your expression, your functions into your string wherever you want. Okay, very good or very flexible format or syntax. Here's another example. I have a equal 4, b equal 5, right? If a is backslash parenthesis a, you're going to show this variable, which is 4, and the b is backslash b is 5. So you're going to see the number here. If a is 4, b is 5, then you see the variable a plus b equal backslash parenthesis a plus b. So that is the expression here, right? You have a two variable, add them together, which is expression. You can put it into inside this parentheses. Right? So it's very flexible, right? So you can see backslash parenthesis a plus b. You are going to calculate a plus b first, and then convert it to string and show the result here. How nice it is, right? So you're going to see the very neat or very nice format, and insert a, b, and a plus b into these strings and show the very nice output of the strings. So this is the one, remember, okay, you are going to learn this one and using this one very often. Backslash parenthesis. Inside the parenthesis, I have all kind of variables, expression, functions. Okay. Right. So next one, let's see the string equality and the comparison. Okay, when you're trying to compare the two strings, okay, to see if they're equal or not. You say months, January. Okay, other months, January, right? And the lowercase months, lowercase j, January, right? So Swift language, like all the other most of the languages here, it's so-called case sensitive, right? If you compare this month, okay, this month with other months, they are the same because j is j, a is a, and then n, okay, they're equal. But if you compare to this lowercase month, the j is a lowercase. Okay, j is a lowercase, so it's not equal the j uppercase. They are not equal, right? So you can see months, they do the same comparison, okay, using equal, equal, okay, equal, equal, and this equal, equal comparison, you're going to get the result of the Boolean type, right? If they are equal, true. If not equal, false, right? So if you do this one, and of course, this first month and other months are the same, they're January. Okay, so they are true. Since they are equal, so this output should be true, and then you're going to print out they are the same. Next one, okay, month, okay, which is a capital J, and lowercase month, it's a lowercase j, they are not the same. But be careful here, we're going to use not equal. Since they true, they are not equal, the logic output here should be true. So they still go to this inside of this if statement, they can print out they are not the same. You can see the result here. Yeah, result here. So again, okay, the string in the Swift is case sensitive. Right, you have to be sure exactly compare the lowercase or uppercase. There's another function we call the lowercase. Okay, L-O-W-E-R-C-A-S-E-D. You see the parentheses here? Okay, which means, okay, this is a function, right? So you actually had a name, okay, called Johnny, okay, Appleseed, and actually you call the lowercase the function. So all the characters is becoming lowercase, right? And then you're going to compare this string here. Be careful here. You see, we're going to put this string in the double quote, okay? They are going to have a capital H, capital Y, capital P, and capital D, right? But this is a string. We are going to put in a string, right? So actually in the memory, they're going to have a string object generated, right? And so this object actually can call lowercase also, right? So you are going to compare the previous names, Johnny Appleseed, lowercase, and then this very funny Johnny Appleseed, okay, uppercase, lowercase mixed, and then you call lowercase again. Okay, these two should be the same. because everybody is lowercase, right? And then they say two names are equal, right? So this lowercase is a function. You can operate it, okay, with a different kind of strings. Okay, every string actually, again, every string is a object, okay, and this string object can call this function called the lowercase, make sure all the characters becoming lowercase strings. Also, okay, besides this lowercase function, there's lots of the other functions. Okay, two of them called has prefix, has suffix. Okay, let's see. Okay, I have a greeting string called hello, comma, world, right? And then I'm going to call has prefix, hello, right? So this is a greeting variable. This is a greeting variable. You're going to check. So has prefix means, okay, you are going to check this hello inside this greeting string. Do we have this hello in the prefix? Okay, at the beginning of that string, right? You can see here, H is capital, ELLO we have here. So this has prefix actually return Boolean type, okay, true or false, right? So this guy is going to have a true because we have a hello in the beginning of this greeting string. Yeah. Another one is has suffix, okay, word. Okay, now greeting has suffix word. Be careful here, since all the strings are case sensitive. There is a lowercase word and there's an uppercase word, right? So let's see what is the original greeting strings. Actual original greeting string is a lowercase word, right? So let's say go back, has a suffix lowercase word. So this one should be true. You got in the end, suffix means in the end of the string, you have a word, okay? And the last have suffix word, because this word is a capital W, okay? They do not have, right? Because you only have a lowercase word, right? So that's why the output should be true, true, and false, false. So this is another two function, has suffix and has prefix. Now there's another one called contains. So inside of your greeting string, in this case, we have hi, Rick, my name is Amy. So this is your whole string. Now, you say, is this string contain my name is? Okay, so you're going to substring this one called my name is, searching for this my name is, if this my name is contained inside of your original string, right? So this one actually is. Okay, we have a my name is Amy here, right? My name is, we will contain it. So this function also return true or false. If you contain it, it return true. If you don't contain it, okay, it's return false. Right? In this case, it return true. So is this if statement is true? So I'm going to print out make an introduction. Right? My name is. This is the introduction. So this is a way. Okay, this is a contain function. Contain function. Let's see. Also, we have a count property. So let's say your string actually is a object. Okay, and we'll learn this later. String is an object, or you say the class type of the object. Okay, and then you can call a bunch of the functions, right? Like contain, have suffix, have prefix, right? And these functions. Now also could have some kind of properties. Okay, count is one of them. You got a string, okay, and I have this count, mean how many characters you have inside of the string. In this case, name, Ryan Mears, right? This one actually had a 10 characters, including space, right? So this one actually equal 10 count, right? So if you say name dot count equal count, this count is assigned to 10 because this string has 10 characters. New password 1234. Okay, this string actually has a count with 4, right? 4 characters. Now you can do this. Okay, say new password dot count. You count how many characters this new password string has, less than 8, and then you print out. So you say, oh, this password is too short. Okay, you need a minimum 8 characters for the password. Right? This is a normal way to doing it. So you just say compare your strings.count with some kind of character 8, right? To do it. And also you can using switch. Okay, so this is one, okay, used very often. For example, we define some character. Be careful here when you do the character, right? You have to explicitly show this is a character type. Okay, CHAICTER, this is a type, and then use a double and put one single character in the double quote. If you don't express the character, you're going to get a string instead of the character, right? So this is a specific type you have to put in here. And then you have a switch, okay, some character. This switch actually can have a case, A, E, I, O, U. This is a vowel, right? So you can use in case or one at a time, or using this one, put them together. You're allowed to do this for the switch syntax here, okay, and then column here, right? So as long as your character is one of these, you have to print out they say this character is a vowel. And the default, if you are not A, E, I, O, U, you have to print this character is not a vowel, right? So this is a switch case syntax to use it. You can use it. All right, so we talked about the string and the multiple functions here, okay? And there's actually lots of functions. Normally, you say this is called a string function, okay? String function for all kind of languages, okay? And especially modern language, they provide a long list of the string functions to help you to manipulate the string, okay? Manipulate string, because we know, okay, and in the real world, okay, you are going to add some string, delete some string, insert some string, or got a suffix suffix, right? And all this kind of functionality, very useful. Now, besides this lowercase has prefix, has suffix, contains, right? You have a lot of the other properties and string functions you're going to use, right? Like a star index, end index. These are maybe properties. And then let's see the function here, okay? Because the previous one actually is you see start index, end index, there's no parentheses in the end, meaning they are property, okay? And the next one, let's say index, before index, after index, all of these you see has the parentheses here, and all of these are just the functions, okay, functions. So all of these are one, and sometimes may be useful using it, and you can go to your document of your Swift, right? Detail about the string. You're searching for the string class, and they're going to show all the detailed functions you can use to manipulate or dealing with the string. Unicode. Unicode actually is, I think, and language like Java or the Swift, okay, they actually using Unicode. Okay, because nowadays your app is not only using one language, okay, it could be all the other kind of languages. So make sure, okay, you are going to using Unicode, and then your application can convert to all kinds of other languages, which is convenience for you. Now, for the Unicode, actually, let's say when we're doing something like the ASCII code, okay, English A, B, C, D, E, F, and 1, 2, 3, 4. We have total like 256 characters, okay, and that one only need a like 8 digit, okay, for these kind of numbers, okay. But for the other language like Japanese or Chinese, okay, they have thousands of the basic characters. Okay, you cannot use in like 256 to represent all these characters, right? So that's why we have the Unicode, okay, and which is going to have a 128,000 different kind of characters, right? So of course, yeah, you cannot using 1 byte, 8 digit to represent one character. You are using 4 digit, 4 byte. 4 byte should be 32, okay. and minimum digit to represent the characters, right? That's why you got 128,000 different characters, right? So let's say this kind of emoji, the cow, okay, symbol, infinity, or kaji, okay, and Japanese or Chinese, okay, these are, you also represent one character here. Even they are not going to using 1 byte to represent one character. They could be having 4 byte to represent one character, which means in the Swift language, this cow emoji, okay, or this resume, okay, or this infinity, this kind of symbol only represent one character, okay, even their encoding has a 4 bytes to represent them, right? So you can see later on, you can see double inside here, right? The cow, if you put the emoji here, right? This emoji maybe need a double 2 bytes or 4 bytes to represent these characters. But we will say, what is the count for count? COW. Let me see if I can run this guy in our playground. Okay, cool. Okay, now, so let's say I'm going to print out this cow. All right, so I'm going to run it. Oh, I'm still have a hello problem here. What is it? And delete it. Okay, you can see the cow printed out here, right? Okay, now I really want to say how many characters this guy count, right? So we have the property called count. Count, right? It's going to say how many characters this guy is. Actually, it should be 1, right? So let's see here. We got 1. Okay, which means, okay, they are going to consider this emoji, even how big, okay, this encoding is. It could be 2 bytes or 3 bytes, 4 bytes, right? But still count is a 1 character, right? 1 character. So I'm going to do it. I think we have another one here, infinity. Okay, character count. Okay, it's interesting. Infinity here. This one should be same thing here. Okay, I'm gonna say, you see here it's a double quote. They're gonna put infinity inside of double quote, means it's a character here. Oh, they got characters. How many count? Okay, this is another function. Characters here. No, okay, it's not a characters. The count of this character should be like this. Let me see if I can run this. Okay, 1. Okay, same thing. Okay, they put a double quote. Okay, infinity inside a double quote means this is a string. Okay, I want to see how many characters inside of the string, right? You're still using double quote infinity dot count. It's going to show still should be 1, right? So they can consider infinity is a 1 character, no matter how many bytes. Okay, this number encoded. All right, so we finished about string. Okay, string. Let's go to next functions. Okay, and for Swift, the function definition is totally different. I mean, it's not totally different. It's very different with Java. Okay, with Java. Normally, in Swift, you have to say function. It's a keyword func, right? And then function name, and then the parentheses. Okay, inside the parentheses, your parameters. You can 1, 2, 3, or multiple parameters for this function. Return type, okay, using the arrow, okay, dash, greater than, okay, this arrow show return type, and then curly bracket, braces, and inside of that, that's the body of the function, right? Which is totally very different with Java. Okay, normally Java is going to have a return type. Okay, there's no keyword called a function, right? And then function name, then parentheses, and inside the parentheses put variables. Okay, put the variable you want. Now in this here, you have to using function func as a keyword, then function name. You didn't put the return type in front of function name, right? And you are going to using arrow point to that is a return type. Okay, and this one is little better because lots of modern language using arrow to point to return type means it's. Go ahead.
Are the return types the same in Swift as in like Java?
Is Java return type should be the function, I mean the return type, function name, and then parentheses?
No. What I'm asking is if in Swift are the return types the same, like void, main, all that, like the same as like Java?
Main's not a return type.
Oh, return type could the type could be the what? The type we're talking about here is
I'm sorry.
integer, not a variable or constant. Should be the integer, string, double, all this kind of type.
Yeah. Never mind. Just
okay. Yeah. It's like a void. Void is one of them. Actually, we don't have a void and here. And if you don't have a return type, you don't write this part. Okay, I'll show you.
I was asking about.
Okay, for example, this here, tie my shoe. This is a function, right? Okay, and actually, when you run this function, okay, there's no return type here. This is not definition. This is actually tie shoe is a how you run this function. Well, now, what is the definition for the tie shoes here? And okay, we didn't see here. You have to, when you define a function, we have to the function. Okay, this function, for example, display pi. We don't have arrow here. You see, display pi parentheses, because it's an empty parentheses, we don't have a input variable. There's no arrow point to the return type here, which means we don't have return type. We don't have a return, right? So it's like a void in the Java, right? We don't have a return here. If you don't have a return, just don't define a arrow and then return type, right? Now, these two actually is a type for function call. When you call function, you say tie shoes, and this one actually is another. This tie shoe actually here means this function definitely do not need a input parameter, right? Do not have a parameter. Now next one, we have a make breakfast, right? Make breakfast, food, egg, orange juice, or food, cereal, toast. This actually the input parameter, which means it's a string array, right? This is a string array we're going to be using as an input parameter. Now, these two actually is a way that the document here just want to show you how to call this function. And then you can imagine, okay, oh, this make breakfast actually is need a input parameter, which is a type of string array, right? Now, display pi here, this is definition. Okay, definition. Now, let me actually doing this. When you actually function here, this is a function definition, right? Okay, so let's going back. Okay, let me see. I'm going to copy this make breakfast to make things a little interest here, right? So, okay. So this one actually is a function call. Make breakfast. Before, actually, this is already you call this function, right? Make breakfast. Now, let's say, how can you define this make breakfast, right? You will know function, so you have to do function, right? Make, this is name, breakfast, right? So this is one, and then you're gonna have a definition for your parameter, okay? Let's say you have a parameter, normally you're gonna have a parameters here, right? And then when you do the parameter, you have to give it a name, actually. The name here, let's say you are going to get this guy called food. Actually, food is an array, okay, string array. You can see like this, using bracket. Yeah, we're talking string array later. String. You can do like that, right? And then do we have a return type? Look, so we don't have a return type here. And then you have a parenthesis here. Okay, and inside of that you can define all of these. Okay, how to make breakfast. Right, so define here. Right? So these are definition here, and then you are going to have a food here, okay, with a string array, okay, with egg, orange juice, something like that. You can call this function. This is actually a call function, and this is a real definition we're talking about here. Right? Let's see if I can run it, and if it's no problem, because we didn't do anything yet, right? We didn't do anything inside a function. So when you call this function, nothing happened here. But this is actual definition. Okay, we have several practice. They say, oh, you got a function, and then you decide you have to figure out how to call this function, or vice versa. Okay, we have a function call. Then can you write down what is the definition for the function is? Okay, we have this kind of practice later, right? So basically, you know, this is a function called make breakfast, and this function need a string array as input, right? So this is seems like that, string for the string, and then this one there's no return. Okay, there's no return type. Okay, if you have a return type, let's say return. I'm sorry, this one should be a greater, right? You got a return type. Let's say, and should be return integer, okay, or double string. Let me see string. Okay, so you're going to return a string, and then inside the function you have to explicitly return, okay, and some kind of string. You can do whatever, okay, for breakfast. Okay, you're going to do that. Okay, otherwise, if you don't have a return, you're going to have a compile error, because you said, oh, I need a return string, but it didn't return. Okay, when I run it, I'm sure they're going to compile it, going to complain, right? So missing return in function expected string. Okay, so I'm going to return here. You have to explicitly return, okay, and because your definition of function, you need to return, right? So in that case, when I run it, there's no problem here. The compile is passed. Right? So this is a function. Let me keep going. Right. So let's say this is a display pie. There's no return type. You only print out the pie. Okay. Then how you call, right? You just say display pie parentheses. That's it. Okay. No return type. They're gonna show the pies. Now the parameter. Okay. How you're using it, how the definition it, right? Let's say function triple. Okay, I have function triple here, and the input variable is integer. You need to input an integer for this function. Okay, and then you're using this value, this input value times 3, and equal to result, and then print out. You see here, we don't have a return type, so there's no return statement here. Then you're going to call triple value colon 10. Be careful here. Anytime you define this variable name called value colon integer, which is type, right? You have to always using value colon 10. Okay. Now my question for Madison, can I call when I define the function like that, function triple, right? Can I call function say triple parentheses direct say 10? Can you guess?
No.
Okay. No, you're right. Okay, you're right. Okay, this is a little different with a Java. Okay, when you actually define the input variable here, right? You can directly say triple 10, directly say 10. But in this case, you have to say value colon 10. Is specify what is the value to doing it. Okay. Now my question still for the Madison. When I can directly call triple parentheses 10? Do you know?
when you,
let's say I'm going to copy this function into my playground. Yeah, just give me a minute. Yeah, maybe understand what I'm talking about here. So I have a function here, right? Called triple, right? You can see that. Okay, we'll define a value here, which is integer, right? Result, and so you're going to print out 3, 1 here. Okay, so I'm going to call this function, right? Triple. All right. In this case, you say value colon 10. Right. This is typical way to call. So let's run it. So if I run it, what is going on? It's supposed to be print out. Hold on. Yeah, maybe it's that too long. It's not respond. Okay, run it. You guys also can do yourself. Open that online playground and play with this guy. Why is it not working? Oh, I want to delete that one. It's triple, right? Let me see. Oh yeah, okay, here we go. It's just a slow, okay. So you see here, if you multiple 10, right? This is the value, backslash parentheses value here, you get to the 30. Okay. My question here is, if you call triple, right? 10. Okay. I suppose you can call this one, and how can you change this function and make sure you can directly call triple 10?
do you take out value? Or do you
Okay, take out the value. Then what?
Oh, take out the colon too.
Okay. I'm sorry, yeah, this one's a little bit difficult. Normally, if you're using 10, actually using the underscore, right? And but you have to calculate the value here inside. Okay, you can do that. And colon. Okay, this will make it work. Okay, come on, this guy is going to have a compiler issue. Yeah, okay. Okay, now it works. Okay, later on, yeah, maybe I think maybe everyone should read that. You actually can have 2 names for the variable. Okay, one is for outside. Okay, the other one for inside. Okay, you see here, if you're using underscore, means from outside. When you call this function, you don't have to put any value here, but this value could be used inside the function here to doing it this one. In this case, you don't have to put triple value colon 10, okay, because it's underscore here. Okay, underscore means you can escape the outside variables. You don't have to using yet when you call this. Okay, but internally, because I'm using this value internally inside of this function, right? Okay, the value here, you are using value backslash parentheses value. Okay, to using that, That's why I'm using internally. Okay, from outside you can call this one. Okay, but if you call from outside, you could complain. Okay, using the value here, they're going to be complained. Okay, because the value should be inside using only because it has a column here, right? Now, okay, this since I'm here, I can talk too much, and I'm going to change one. Okay, just say out value. Okay, and doing that. In this case, how can I call this function? Nicholas, if I do that, how can I call this function?
Oh,
Yeah.
I forgot this one. It should let you do either or, where you can either do the value tag or.
Yeah, this tag actually is outside. Okay, this tag is inside. You see value here. Okay, only using inside for just for the inside function. This outside you have to use outside, which is called out value, right? Colon and 10. In that case, it's gonna be work. Okay, you see the result, the printout. Okay, so when you do extra function definition, one variable you can give it two names. Okay, the first one should be for the outside, the second one from the inside. Inside means just definition used inside the function definition here. This value here only use inside, but outside you can use the out value here, put outside when you call. Okay, and in this case you cannot call 10. They're gonna complain because you have value name here. In this case, they're gonna complain, right? Out value. And if you don't want this guy, right? And you can use the underscore to escape it, and then this one can do work. Run.
Is there a variation of this where you can make it so that you can optionally use the label during the call?
Yeah. Option. Yeah, option is another case we're going to talk. Okay. In this case, actually, one variable you can give it two names. One name used for outside. Okay. And the other name is for the inside. I'm sorry, this one is going to be. That's a topic.
It looks to me like the out value pattern, the outside label pattern, is what's going on. Also, though, when you like say I don't want to use a label, right? Because it's basically treating the underscore as no label.
That's correct. Okay, that underscore means outside. I don't want using label. Okay, you see here. This is the way you're doing. It's typical like what Java, right? The way you call it, you don't have to specify the value name, right? And if you have a multiple, you can have multiple. You use the column comma to separate them, right? And in this case, if you don't want to value, it's like Java, you can do like that. Call variable just directly put integer here, and then in the definition here, you can use underscore. Right. Yeah, I think I should have example later. Okay, I'm talking this one. Since I'm here, I just talk too much about this one. Okay, but basically, at the very beginning, when you define a function, okay, this is a variable name, right? Value, and you have to using triple value colon and then the variable name, a variable value. And another name, another example here, multiple, right? Your first name, column integer, second name, column integer. So this function actually need two variables, first name and the second name. It's their variable name. Okay, this variable name can use outside and inside, right? So inside you say result equal first name times, I'm sorry, not name, number. First number, the second number. They're going to multiply these two numbers, got the result, right? The result is the result. Now, when you call this function, okay, that's a trick here, right? You define function, you call the function. You say multiple, first number, column 10, comma, second number, column 5. Okay, it looks like a hard to tracing, but this is a good habit, especially for the developers. Okay, it's clearly say what is a variable you're gonna when you call this function. Okay, no mistake. It could be happen. Even it's like a tedious, right? But it's much more for the developer or the readers to understand immediately, okay, what is your first variable number value, what is your first variable's name and then the value, what is the second parameter's name and the value. It's much clear. Add them together, right? And same thing here, okay? And another called argument label. That's what I'm talking about here. For example, say hello, first name, right? String. This is your parameter for your function originally, right? First name. And then say print hello, first name. Right. Now, okay, and then say hello, first name, Adam. Okay, and sometimes you say I want a function call to say hello to two person. Okay, and the two person actually you are going to using the two variables, right? You say hello to Miles and Riley, and these two strings, okay, you are using variable to and end, but internally it's going to make no sense. From outside, you say, oh, say hello to Miles and Riley. Okay, when you call this function, makes sense, right? So our first variable is to, second variable is and, so two person. But when you do this to and and inside of your function, say hello to and end, make no sense. That's why, okay, that's why we introduced two variables, okay, one for external, the other one for the internal. Okay, this is a complete one. Okay, function say hello to person colon string comma. Be careful here. All of these here just for the first parameter. After comma and another person colon string, that's another parameter. Two parameter, right? So you can see to and is used for outside. Okay, so function say hello to and string. Okay, two person like this one. Say hello to my and Riley. To and these are the two, right? And then the person, another person is used for internally. Let's say hello person and another person. This one should make much sense inside of your function, right? That's why we define a function. You can have a two names, okay, for each parameter. So the two person and another person. So you can using these kind of definition. Okay, of course, this one just a string to doing it. When you call it from outside, right, you are going to use the first parameter to colon mile and Riley. Make very sense, right, for this kind of function calls. Now you actually can, that's what I say. For example, if you want to have say hello, I say hello to Luke and Dave, you don't want to put to an end, right? Luke and Dave, these are the two strings directly call. It's like Java call. Okay, you are going to put the two parameters directly in it. You don't have to give it a parameter name. Okay, that's the definition here. You have a underscore person colon string comma underscore another person colon string, right? And this second variable name is for the internal use, right? Hello backslash person and backslash another person is going to be for internal use, and for the outside, okay, there is underscore, which means you don't have to claim what is a variable name or parameter name in front of it. Using underscore to definition, right? This is a little tricky, especially when we just started with the Swift language, right? And but slowly, okay, when you do the function call, slowly you are going to be familiar with the syntax, and then normally the practice is like this. Okay, you have a function definition, then say how to call the function, right? Or you say when you have a function call, how you convert it, you reverse to do, okay, what kind of function definition should be looks like. Right? So these are the things, okay, we use it very often. Okay, slowly you're gonna familiar with this kind of format. All right, and the default parameter value. Okay, it's same thing like Java. Okay, sometimes you want to set some kind of default values from parameter. Okay, so later on, because lots of function calls, they use default. Okay, I don't have to assign it, but some specific cases they need some kind of variable differently, right? So you can define so-called default parameter value. Here's the definition here. Here's an example here. Function display team name, okay, string score integer equals 0. Let's say they just start as a team, okay, and always, of course, your score should be starting with 0, right? If you want to start a team, okay. But sometimes they say you already got a team and they already have some kind of score. You can define the score for the second parameter, okay. Oh, be careful here. All the parameter is going to assign a default value should be put in the end. You cannot put something like in the beginning. Okay, the first parameter and then the second parameter do not have a default. Okay, so you only put your default value parameter in the end. Okay, if there's only one default value put, should be put at the end. If you have two, if you put the last two. Okay, you cannot put the very beginning. So these are the rules for that. And here's a typical example here, right? So you can say this is definition for the display function. You are going to have a score, which could be a default value equals 0. So you can call this display with the team name 1-bets, okay, score 100. You can sign this 100. Or you even don't put the second parameter here in second call, okay, and which means this score should be equal 0. Okay, equals 0. Right, so this is the default value. You have to put in the end of the function, and you can define it. And then when you call it, you can sign this score, okay, or input this score, or you don't. If you don't, basically the function is going to be using the default value. Return value. Okay, return value actually is, as I talked before, you are going to using arrow point to the type. You see the type integer here. So you had a function called a multiple. You have two numbers, first number, second number. Of course, when you do the multiply these two numbers, you have to return the multiple, right? And so you have to return integer also. So let's say this is the whole full definition here. You got a first number, second number, return integer. You got a result, first number times second number, and then you have to explicitly say return some value, right? So return result should be integer, right? Because your integer times integer should be integer. This result should be integer here, and then you return it is the exact match this type. Okay, so your return value have to be match the definition here, right? And also you can do this. Okay, you don't have to sign your multiple. Okay, first number times second number equal result. You can directly say return first number times second number. You can save one variables directly, right? And here's a way to call these functions, right? Let's say let my result equal multiple first number 10, second number 5, right? So you want to multiply 10 times 5. You can using this print, okay? Double quote, everything put in double quote. I love that. Everything put in double quote, and then 10 times 5. That's exactly the string is. Then in the backslash parentheses my result. This is this variable and call this function. So this function actually return the integer and then sign to this my result. And also you can do this. Okay, that's what I said before. Using backslash column, parentheses, you can put your function code directly inside this parentheses. Okay, you can see here backslash parentheses, multiple first number 10, second number 5. So this function call actually return an integer, and then this backslash parentheses convert this integers into a string and then print it out here. Print out here. All right. Okay. So this is function. We're down here. So now I'm going to talk about structure and class. Okay, for the next ones. All right, let's have a brief break. 5 minutes. Any questions so far? All right. If it's not, and let's have a 5 to 10 minutes break. Okay. After break, I'm going to be talking about structure and class. Right. Structure class. Okay. So because you just raise your hand, you just for the attending, right? Not a question, right? You can talk, yeah, just directly.
Yeah.
Okay, that's a question. Yeah, if you have a question, just directly talk, right? Just directly ask. So we have when we're talking about the structural class. Okay, it's like a prototype. Let's say, okay, I have a a I have a structure called a person, which is going to have a name in it. Okay, this is just like a definition or prototype. Now, when actually trying to know which person you have to so-called instantiate, got an object. Okay, now when you define a class or define the structures, okay, in the computer language, normally there's some places say, oh, this is our structure definition or class definition. In this case, I have a structure called a person, and then you know, okay, this person should have a name on it. Now, if you want to specify specific person, or you can say instantiate the object. So inside the memory, let's say, first person here. I have a person, parentheses, name, Jasmine. Now, when you actually instantiate this person here, that define like implement like that, actually in the memory, you are going to have a specific place for this object, person object. And then inside of this memory, there is a name variable called Jasmine in it. Okay, so this is the first person you instantiate. You can instantiate second person, third person, okay, 10 person, 100 persons in the memory. So you're going to have 100 object in the memory, and each person has a different name variable in it. This one we called instantiation. Okay, you have to instantiate your class or structure and got the real object in the memory, right? So this is definitely, this is a concept. Okay, when you define a structure, when you define a class, it's like a prototype. Okay, it's a concept over there. But if you want to get a real person, real class object, you have to so-called instantiate it, right? Instantiate it. Now, let's say this structure, the person structure, right, will only have one property called name. Okay, so every time when you want to instantiate this person, you have to give it a name. That's it. Okay, that's it. Now let's see the other example here. Okay, when you do actually define a structure, it's not only you can assign different kind of properties for this structure, you actually can have defined a function. Okay, because this object could do something, right? So this person can say, oh, this person wants to say hello to anybody, just introduce himself, right? So this is actually a function you can define inside of a structure and the class, right? So this is a name, is a property. So inside of a structure, you can have a different kind of property, and you can have different kind of functions, right? So this is just for definition, prototype, or concept. Now, when you actually instantiate your structure, like this one, Jasmine here, you got the person named Jasmine, right? And then you got this person object. This exactly you signed. When you instantiate, you got the structure name, give it a name, okay? And then this whole thing is going to get so-called object created inside of your memory, right? So, and then you will assign a variable called object name. So this lowercase person is actually the object, okay, and represent this object, structure object, right? And then you can call functions using this variable person, say hello, right? This is function call, right? You can see the parentheses in the end. This is function call. So when you call this function, actually it's going to print out, hello, there, my name is Jasmine. So when you actually instantiate your structure, you got an object in the memory, right? And then this object can represent all kind of properties this object have, and also can call a functions, okay, for this object. So this one, okay, we call it instance. Okay, you can also got instances, right? This is one. Let's see another structure, okay, called shirt. Okay, this shirt had a size, color, okay, property. So when you actually instantiate this shirt, okay, you have to decide what is the size. Okay, this one got X large, color is blue, right? And your size, you instantiate another shirt, okay, it's a medium size, it's a red color, right? So you can use this kind of instantiations to guard the object, okay, guard the object. Now, let's say another example here. Let's say car, it's a structure. We're going to have a more, okay, we're going to have a more property for the car, right? Typical one, we should have a string, we have a make, module, year, and the top speed. Okay, when we talk about make and module, that's string. When we talk about year and the top speed, they have an integer. And then you can define this structure, okay, this car, okay, we're talking about this car, right? Okay, start engine, okay, then print out, oh, your engine start. Drive, park, different kind of functionalities for this structure doing it, right? And then when you instantiate your car, actually say car, parentheses, and then in this car structure actually has the 4 properties, okay? It has the make, Honda, module, Civic, year 2010, top speed 120 miles, right? So these are the ways when you instantiate your car, okay? And then after you instantiate your car, you got this first car object, and then you can call function. You have to, these function call we call them member functions. So every time this member function, you have to instantiate this structure, got an object first, and then using this object to call all these functions. So this first car actually is an object. When you got this object, you're going to call all these functions, which is shown here, right? And then actually you can instantiate another car object called second car, and then you can call first car dot start engine, okay, first car dot drive, right? And the second car, you didn't call any function, right? So the second car is still there, but the first car is already start engine or it's already drive. Okay, you can see the result here. So that's a typical way. Okay, we call it object oriented concept here is you got a structure, you got a class, and then you have to instantiate it. Instantiate means you customize, you got a real object. Okay, the original structure or class called conceptual or the prototype, right? But if you want to get a real life object, you have to instantiate it, gather the object, and then you can call all this kind of functionality doing things. Right, and for the initializer, actually we already see, okay, the initializer, right? You just set all the properties with the values, okay, with the values. Now let's go back to a other object. Let's say string, integer, boolean. Okay, when you actually talking string type, right, integer type. Now this one called a car type, or previously is a person type, right, with a specific structure called a type. Now if you're talking about the internal type, we have a string, integer, boolean, all this type. actually can consider these as a structure and the classes. Okay, and most of these are the classes, and some of them are structure. Okay, but when you actually try to instantiate it, okay, you can call initial functions. Okay, you call it ini, or you can say string parenthesis, integer parenthesis, boolean parenthesis. Okay, these are the two ways for this kind of internal default types to instantiate your string, integer, boolean value. Okay, basically this lowercase string, integer, boolean, it's an object name. It's already object, right? You can use it ini or just a parenthesis to instantiate your string value, your integer value, the boolean value. Okay, there's initial value for the string is empty string, for the integer 0, for the boolean type is a false. Okay, when you instantiate these values. And it's the same thing, okay, if you want to do, okay, as an object, okay, like a car or person or something like this, right? And actually, for some kind of properties, you can set a default value. Okay, like we have here, a string, integer, boolean. String is empty string, integer, and is a default 0, and boolean default is false. Okay, when you do your structure, you actually can set this kind of default value. Okay, like this, right? So let's say structure odd meter. Okay, odd meter actually set there is this structure has a property called count. Okay, and then you can find equal 0. Okay, this is actually the initial size. And then you say let odd meter equal odd meter parenthesis. Okay, in this case, you are going to, you see, you didn't input any count here. Okay, you actually can get the initial value, which is 0. All right, of course, when you instantiate this odd meter 1, I'm going to show you here. Okay, so this one odd meter, right? You got it here. You're gonna print out odd meter, which is 0, default 1, right? So I'm gonna do run that. Okay, I have to refresh again. Okay, 0. Okay, let's see here. This is 0, right? So I'm going to got another one. Okay, let's say let odd meter 1. This is odd meter. One here, right? And then you say, okay, I'm going to put a count. Okay, 100. Okay, 1,000 miles. Okay, so you are going to get this odd meter 1, right? Let's say print odd meter 1 count. Okay, I suppose this one should be 1,000, right? So when you actually instantiate, this is your structure. Okay, this is one instantiation. You didn't specify the count. They're going to get the default 0. And then you say, I'm going to instantiate odd meter 1, another object. Right? You're going to see the 1,000. Okay, so you're going to, when I print out the count, it should be 1,000. Right? Let's run it. Okay, the first one 0 because they didn't give any value for the count, which is 0. Second one, you instantiate this odd meter 1. Give the 1,000, so you're going to print out a count, which is 1,000. So this is the two ways of doing it, and the most of case we do this kind of instantiation very often. You can set the variable. That's exactly like the default ones for the internal type, like a string, integer, boolean, here like that, right? And you can do yourself here inside the odd meter. Okay, you can assign the value doing it. Now, member-wise initializer. Okay, you besides this kind of things, okay, you got one variable initialized here, right? You got to say originally it's 0. You can do it. You actually can have any functions, I think. No, this is one. Okay, well, we just did. Okay, we just did here. Odd meter. Okay, you can instantiate with a member. Okay, member variable count is 27,000, right? And same thing here. Okay, for the person, we have variable here, right? And actually have person, and you actually say name Jasmine. Okay, you're going to assign a Jasmine to put inside the person name, and then got the person object here. Now, there's another one, shirt, right? You can construct shirt with the size and the color. Okay, you're going to say shirt, size, color, X large, color, and blue, dark blue. Right. Same thing here. Okay, when you instantiate your car, right? You actually instantiate with the initial value Honda Civic 2010 and top speed 120. Okay, 220. Now it's interesting here. To do the customized initializer. Okay, here's a typical example here. Let's say I have temperature. Okay, and inside this structure temperature, I have a Celsius double value. Right. Now, so when you actually instantiate this temperature, okay, then you say Celsius 30.0. Okay, 3 Celsius. You are going to get the temperature of object, right? So this is the normal customization initializations. Okay. Now, if you're using Fahrenheit, right, and lots of Europe using the Celsius, and also but the USA using the Fahrenheit, you have to change your Fahrenheit, to the Celsius, and then construct this temperature object, because this temperature object only accept the Celsius, as input, as input. Now, there's a couple of ways, if you want to convert, Celsius and Fahrenheit. This is a typical one way here. You say inside the temperature, I still a property Celsius, still have the Celsius for the property, but I have any function here. So whenever you construct instantiate your temperature structure, you are going to use a different kind of init functions, right? If you are input Celsius, you are using init Celsius. If you input Fahrenheit, you are going to use the init Fahrenheit function. Okay. And then for this init Fahrenheit, you are going to convert your Fahrenheit to a Celsius, because this temperature only have a Celsius as a property, right? So this, if you have these two init, and then you say current temperature equal temperature Celsius. If you use a Celsius, give it a Celsius, and then you can construct a current temperature. And then you can using another way, using Fahrenheit init to instantiate another temperature object called boiling, right? So this is Fahrenheit 212 degrees, which is the boiling point. But of course, it's 212. It's going to convert it to the Celsius and sign inside of the Celsius properties to insert it. So when you print out, actually it's going to print out a Celsius 100. You see here, even your input the Fahrenheit 212. This 212 is converted to the Celsius here when you instantiate. Construct or instantiate this object, right? And then when you print out, you actually print out Celsius here, which is 100 degrees in Celsius, right? So basically, 212 Fahrenheit equals 100 degrees Celsius. So this is a init. Basically, you can add any function to accept different kind of instantiations, right? You have the Celsius variable here, Fahrenheit variable here, and then when you call this constructor, they are going to match. If you have a Celsius, they're looking for init file and find the Celsius. Oh, this is a variable Celsius, and then they're going to call this function. If you have a Fahrenheit, they're going to have call this init and they got this Fahrenheit and they calculate here. So it's totally dependent on your init file. And in the Java, I think they called the constructor, different kind of parameters okay, and you're going to get a different kind of constructor to construct your object. In this case, we call it ini, okay, function. You are going to use different kind of variables here, and you are going to call different kind of ini functions to instantiate your object. All right, so we actually can have this one in the right hand side. Okay, even have more. We have Celsius. Okay, we have Fahrenheit, and we have Kelvin. Okay, normally Kelvin is for the professional. Okay, to calculate the degree. And then you are going to instantiate, right, using these three ini functions. Okay, Celsius, Fahrenheit, and Kelvin, and got these three objects. Okay, and then you can print out all these three objects Celsius property, because for this structure I only have one property called Celsius here. Right. All right, and so besides this ini function, okay, we are talking about another one called instance method. You actually can define as many functions as you want inside the structure or class. Okay, so in this case here, we have a size structure. Okay, so this size has a width, has a height, and then you're using this width and height to calculate an area. Right, it's a rectangular, and the width and the height, and calculate the area. And be careful here, this function has a return type, which is a double. You have to using return. Right, in this case, it's shortened. You just return width times height. Right. So this is the definition for the size structure. And then when you instantiate the structure using size, parentheses, width 10, height 5.5. So you got this width and height, and then you can call area, right? So you have to instantiate this size, got an object, and then using this object value, lowercase sum size, call the area function. Okay, this area function is going to return width times height, and I got this area variable here. Right. So this is one called instance method. Basically, inside your structure and the class, you can define as many functions as you want. Okay, but when you can call this function, you have to instantiate your structure, got an object, and then using that object, call the functions. Right, call the functions. All right, so let's do the other ones. Okay, called the mutating methods. Okay, sometimes let's see here. Okay, this structure function, this size structure, and this area function. You see, this area actually just a return width times height. Did we change this width and height here inside this function? No, we didn't change this width and height, right? So now, if we're talking about structural class, the most important thing is that's his own property. For this size, there are two important variables for this size structure. One is width, the other one is height. Right? Very important, because this size, you have to have a width, you have to have a height, right? When you instantiate the size. Now, sometimes this function don't change these two values, but some of the function is going to change these two values internally, right? So that is sometimes dangerous, okay, sometimes important. So this is a new feature actually Swift introduced. Because these two variables, or whatever variable this structure has, is very important to the structure. So if you want to change these two variables, okay, you have to be careful. That's why Swift introduced this one called a mutating method. If you want to change, mutate means change, right? Mutating means change. If you want to change this variable, internal variable, you have to add a mutating in front of the function. Okay, so every time when you see mutating function, oh, let's just realize, oh, this function is going to change your property. Okay, so let's see what we have here. This structure called odd meter. Okay, this odometer has a count. How many miles? Okay, your car is already driven. This odometer, this count means, okay, this is only property belongs to this structure. Okay, now I have increment. Okay, I have increment by amount. I have a reset function. All these three functions is going to change this count. Okay, so the Swift language demand, okay, you have to add mutating in front of the function because these functions are going to change this count. Okay, so enforce you, okay, notice the developer or the readers, they say, oh, when you see this mutating, you just realize, oh, this function is going to change the property of this class or structure. Okay, very useful. Okay, very useful and makes things very clear, right? Because your internal property is very important, okay, to your structure. If somebody change it, you have to trace it and make sure, okay, this is a function. So when the next develop, join the team trying to change your code, right? And he or she sees this mutating immediately, he just realizes, oh, I have to be careful, okay, because this function is going to change the property of your class of structure. So in this here,
there are other reasons to declare a mutator, though. A method is mutating, right? Because maps and stuff, well, to do parallelization, right? You don't want two methods trying to mutate the same structure at the same time, on different threads or something, right?
Yes. Okay. Yes. Okay. But this mutator, I think only purpose here is if you want to change its count. Okay. Inside this function, you have to do mutating. Okay. This is the only reason here. The other one, there's lots of things like the string mutating or mutating array or the other things. There's the other purpose. Okay. But the keyword here is this introduction, new introduction in the Swift. Okay. You say basically say if you want to change your property. Okay, inside these functions, your function definitely have to add mutating in front of it. Okay, that's it, right? All right, cool. So let's say this is a three functions. You have to add mutating, otherwise the compiler is going to complain. Okay, because this function if you change this count here. Now let's say how to using this guy, right? So you're going to say variable odometer, lowercase odometer equal odometer parentheses. Okay, you're going to construct. Okay. Instantiate an object, okay, we're using the default value equals 0, right? And then you say increment. Increment means this count is +1, right? Count plus equal 1, which means original 0, and then now count becoming 1, right? And then next one, odometer, right? Because if you want to call the functions, you have to use an object, right? Odometer dot increment by 15. By 15 means plus equal amount, 15. So now you're going to become 16, right? 16. And then you're going to call reset function. So this reset function actually going to set the count to 0. So your odometer's count value is becoming 0 now. So when you call these kind of things, okay, every time this is typical function call, right? We call the member function call, which is really, but when you do the definition here, you have to add mutating in front of the function, okay, because these functions is going to change your property count. All right, so these are typical ways. And then there is a property called computed property, okay? And there's another concept called, which lots of other language have called set and get function, okay? And let's see what we have here. Let's say I have a temperature structure, okay? And in this structure, I have 3 variables, Celsius, Fahrenheit, and Kelvin, 3 property, right? And then if you, for example, if you want to set or instantiate the temperature, let's say Celsius 0, you have to set the Fahrenheit to 32, okay? And set the Kelvin to 273.15. So these are hard to maintain because you have to when you instantiate it, make sure these 3 numbers are the same, okay? Otherwise you're going to be a problem, right? So you have a way to calculate it, okay? Several ways to doing it. One, okay, like this, okay, you got a structure temperature, Celsius, Fahrenheit, Kelvin, and then you're going to input as a Celsius, and then you convert the input Celsius to Celsius, convert Celsius to Fahrenheit, and convert Celsius to Kelvin. So internally, Celsius, Fahrenheit, Kelvin could be consistent. This is one. And then you have any function except Fahrenheit, and convert Fahrenheit to the other three ones. Same thing for the Kelvin input. When you input the Kelvin and then convert it to all the three ones, right? So when you instantiate your temperature object, you only need to one, either Celsius or Fahrenheit, Kelvin, and then you have three init function to convert all of these. Okay, but still it looks like that. I mean, there's lots of things duplicated, right? That's a feeling. So there's another solution here, right? Let's say this is structure. Okay, I have a temperature called structure. Okay, I have a Celsius. I have a Fahrenheit. Be careful here. Original property called variable Celsius colon double. Okay, this is typical variable definition, right? And let's see the Fahrenheit. Variable Fahrenheit colon double curly braces here. Let me get next page. Return Celsius times 1.8 plus 32. That's a conversion, okay, from Celsius to Fahrenheit. And let's see the Kelvin also. Kelvin colon double curly bracket. Okay, and then return Celsius plus 273.15, which converts Celsius to Kelvin. Now, so this one, it's like what? It's like a get function. Okay, you got the Celsius, and then you can immediately get the Kelvin or get the Fahrenheit. Right. So this is the definition. We call it computed property. So whenever you try to get one, you only need to input the Celsius, and all the Kelvin and the Fahrenheit can using this computed function. It's like a function call, right? Okay, you use curly bracket here, and it's a return this function. It's like a function call. So basically, it's like a get function. Okay, in the Java or something else, you call a get function here. And I think in the C# they're doing similar things like that. So in the property level, you can add some kind of get functions. You can calculate and then get your property value. Okay, that's why in this case here, in the Swift, they call it computed, okay, property, computed property. So in that case, if you have these two computed properties, so next time you instantiate your object, you only need to input Celsius, okay, and then you got your object, right? And then you can get Fahrenheit and Kelvin immediately because these two properties has internal get function. There's a function call, and calculate the value from Celsius to Fahrenheit or Kelvin. So these two here, okay, you're going to construct like this to do it. This is a lots of the modern language like C# or something doing things like that. Okay, you can put some kind of similar like a get functions in your property. So your property value is going to be calculated when you actually instantiate your object. Okay, all right. And also, okay, interestingly, okay, we have so-called observers. It's also like a function call. Okay, you call the property observers. Let's see. In this case, we actually introduced two, okay, observers. One called well set, the other one did set. Okay, it's like a very previous, like a get function, a get function. Let's say I have a total steps, like this structure called step count. I have a value called total steps, which is integer, initially 0, right? Now, if somebody want to change this value, okay, and then there is a function. Be careful here. We can call this function. Okay, this one called observer, right? Property observer. Actually, it's a function call. Okay, you can see the curly bracket here, right? It's a function. Okay, so when you trying to change this property, this function well set is going to be called. Okay, and then say print about to set total step to new value, okay? Or I'm showing new value later, okay? Did set, if a total step is greater than all the value, then add this one to the steps, okay? Let me see what that means, okay? So let's say you are going to instantiate a step counter, okay? So this is your step counter structure, right? You're going to instantiate it. You're using parentheses. You didn't initialize your total steps. You didn't input the total steps. So your total step equal what? Let me see here.
0 by default.
That's right. Okay, so we got a 0 here. Okay, because you didn't input your total step here, right? You're going to use the default value, which is 0. So your step counter actually is the object here. Okay, internally your total step is 0. Okay. Now you're going to sign. I'm sorry. Looks like this machine connection display. Yes, sorry, my Mac, it looks like disconnected. Let me try it again. Okay, here. Okay, yeah, it's back. It looks like it's something wrong with the browser. So when actually sign, you actually trying to sign this 40 to this total step, right? This is the first one. So when you sign, be careful here. This 40 actually is a new value. What is the alt value for this total step for this object? 0, right? So when you initialize this value, this object, right? When you initialize this object, you got this total step equals 0, okay, which is all called alt value. And then you're trying to assign this 40 new value to this total step of this object. You just instantiate this object here, right? You're trying to assign 40 to this. Now, these two functions is going to call in different time. You are going to call this one first, where set. Before you set this 40 into this total step, this function is going to call. Okay, called where set. Okay, now this one said about to set total step to new value. So you can see here, this is the first printout. Okay, about to set total step to 40. So this where set function, or called observer, is going to call before some value is going to set to total steps. Right? This one is also related with a property, right? So this property is going to change. Before this property is changed, this where set function, or you can say observer, or where set function is going to be called. Right? So it's print out about to set total step to 40, because this is a new value here. This new value should be the right-hand side of the equal. You want to sign this 40 into this total step. Okay, now this function is called. Then this 40 is going to sign this total step of this object. So this total set step equal to 40 right now. Okay, and then this function is called. Did set function called. Okay, so this one actually compare. Okay, what is the total step right now? It's 40, right? What is old value? 0. Okay, so you see here, this is old value, new value. There's that values because these two functions are related with this assignment. Okay, before you sign this 40, right, or after, and actually before you sign this 40 to this total step, your object your step count. Remember, what is my previous total steps? My previous total step is 0. The new one is going to sign is 40, right? So this function well set is called first. You say, oh, what is the new value? It's a 40. So you say about to set total step to 40. And then you have the sign is 40 to this 0 position, right? Original 0. Now 0 is replaced by 40. So this total steps inside this object becoming 40 now. After assignment, then this function did set is going to call. All right. This did set, what does this did set function do? Let's compare your total steps, which is currently now is 40. Old value, which is 0, right? Of course, 40 is greater than 0. And then print add total step minus old value. This is your increment, increased, right? How many steps you increased, right? So basically 40 minus 0 is 40. So you're going to see add 40 steps. So you got to add 40 steps. Okay. And then you are going to actually have another assignment. You are going to assign this 100 to this total steps, right? So before your assignment, you have to call well set first, right? So this one say about to set total step to 100, right? So you're going to assign 100 to this one, and about to set this 100, and then assign the step to 100, right? So it's not 40 anymore; it's becoming 100. After assignment, you have to call did set. Did set is going to get, oh, the new one is 100. Is greater than 40, right? Old value actually is 40. Is 100 greater than 40? And then say add 100 minus 40 becoming 60, right? So you actually increased 60 steps. So they're going to print out add 60 steps, right? So let me repeat, okay? So this actually well set and the did set, these two functions, is actually monitoring before and after you signed to your total step value member here. Okay, before you do assignment, you call well set function. After you did the assignment, you call did set, right? Did set. So it's give you some kind of way to notice, okay, either developer or user of the function say, before you set the value, you show something. After you set the value, you do something, right? It's very like a database, like the triggered or something like that. Basically, whenever you try to change some kind of important values, okay, you can notice the people beforehand and notice the people after. Okay, so these are the ways for these two function or working observer, well set, did set, do. Okay, very useful, and it's a complete new functionality for Swift. All right, and this one, okay, we're going to talk type, properties, and the methods. And this one basically in the Java we call it static. Okay, static. Basically, they're going to define some kind of static property and the static function, right? And when you're trying to use this static property or static function, you're only using class name or structure name. Okay, originally, remember, if you want to access your property or access your function, you have to instantiate a structure, not an object, and then using that object to access a property and the function. Okay, for this so-called typed property or method, or can call static, right? And you can define a static property and a static function, and using structure name to call that function or call to get that property. Here, typical example here. Right? In the structure temperature, okay, we are going to set a static variable using explicitly static variable boiling point equal 100. Okay, we know, okay, boiling point is 100 Celsius, right? 100 degrees Celsius. So every time you want to access boiling point variable, what do? you're using your structure name here. Okay, temperature. You don't have to instantiate your object, right? You're just using temperature, class name, or structure name, right? Same thing here. Okay, for example, we have a minimum function. Okay, for double. Double is a class name or structure name, right? Double actually is a class name, and you don't have to instantiate a double, and then call this minimum function. This minimum function also is a static function, right? You only need to use the structure name or class name dot function name, static function name to doing it. All right, and let's talking about a copy. Okay, and that's a big difference between structure and a class. I'm talking difference later when I talk a class. Let's see what do we have here. Okay, let's say size. Remember the class the structure size, right? And this structure has actually a width property, height property, right? Also, we had an area function for this structure. Now, if I instantiate some size with 250 width, 1000 height, you got this object, right? Now, so we know, okay, so when we got this object, your concept should be have in your mind, have in the memory somewhere, okay, they sit in object, and the one has a width 250 and height with 1000, and put the value inside of that spot in the object. Now, when you assign this sum size to another size, be careful here. These are the two variables here, right? One called sum size, the other one called another size. Okay, now for the structure, okay, when you do this kind of assignment, you assign one structure object to another. If this one is a structure, they actually make a copy. Okay, you can imagine inside the memory there is a sum size object, which include a width 250, height 1000. When you assign the sum size to another size, actually this program just copy this object from some size place to another place. Okay, another place is called another size. Okay, inside this place you have a width 250 and height 1000 in it. Okay, so this kind of assignment is just to make a copy. So now in the memory you have a two object. Okay, object 1 has its width 250, height 1000. Object 2, another side, has another width and height. Two copies. Okay, now if you understand this copy now, okay, now I'm going to change, okay, sum size, okay, from original width dot width, from original 250 change it to the 500. Okay, and then you say, okay, print some size width, print another size width. Okay, you got some size is 500 because you changed it, right? And another size actually is still 250. That is makes sense because you are going to copy the sum size object to another size, another place. So these are total different objects now. So you're going to change one, same size width here, right? 500. You change that. Okay, just change one object. The another object that didn't change. It's a copy over there. It didn't change. That's why you got one is 500, the other one is 250. Okay, I'm going to copy this one here because I need using this one to compare to class later, which is a little different. So I'm copy to our playground. Okay, I'm going to delete all of these others. All right, so you can see here, some size is one object, and I will assign, this size, oh, I didn't have a definition for the size. I have to get the size here. Okay, here we go. So let's do the definition here. Yeah, if you don't have definition, the compiler could complain. Yeah, this concept everybody have to be understand and know how to do it. So have the size, width, and height with double, right? Area. So you have to instantiate one object, width and height, and then this assignment actually, because this is structure, when you do this assignment, actually they're going to make a copy in the memory. So they're going to have two different kind of object, right? So in that case, if I'm going to do that, you can see I'm going to print out a width, and also I'm going to print out the height. You can see that should be the same. Height should be the same because you didn't change the height, right? Because you change the sum size here with the width from 250 to 500, right? So the width should be different, and the height still the same, right? So when I run it, you can see the clear, right? So the sum size width becoming 500 because you changed it, okay? And then another size still 250. Why? Because another size is another copy in the memory, didn't change, okay? The height, both objects are still 1,000 because nobody changed. They're still in a different place as 1,000. Okay, 1,000. I keep here when I talk to the class, which is totally different with this guy, right? So I want to make sure, okay, everybody understand, okay, when you do this kind of assignment here, you can assign one object to another. If it's a structure, it's just a make a copy. You can make a copy. All right, so we're done here. Yeah, I think I'm done with, hold on. Variable property. When I'm, okay, we'll copy self. All right, when we actually do the self, that's a typical way when you're trying to, inside of your structure or class, you want to reference, okay, your object, okay, and you can do that. Let's say I have a car, right, and which car has a color object, color property. There's a description, okay, this is actually the computed property, right, called description. This one going to say return, this is a color car, what kind of color? Actually, this function, this computed property or get function is going to reference the color internally. Now, when you try to reference this kind of property, you cannot direct reference because you have to instantiate a car object and then get object, get the property, right? So they're going to using self.color. Self here means you instantiate this car first, using this object to reference that property. Okay, because this variable color didn't say static variable color, right? You cannot using car.color. Okay, you have to using object name dot color. But this is, since this is definition, you don't have an object yet, right? So normally you're going to use self dot color to reference. Later on, when you instantiate your object, you got the car object, right? So this is your object, self. Okay, so represent the future, you're going to instantiate object and put the object here. And most of language you do, okay, even the Java or the others doing the same thing, okay. Or, okay, for the Swift, okay, much better, okay, you are going to using color directly here. You don't have to say self, but it still means it's a self, right? Means you have to instantiate this car first and then get the color. And also, okay, there's another way to using the self is when you do the instantiation. Let's say this temperature here, right? I have a Celsius, which belong to the property for this structure. And then you have using exact same name when you instantiate your object, which means this is from outside. Okay, typically lots of Java program do this. When the constructor using the construct input parameter using the exact same name like internal property, like Celsius here, right? You have to clarify this Celsius from outside. Okay, so the right-hand side is from outside. Okay, and this one you have to using self.Celsius. You cannot say Celsius equals Celsius. No, the compiler is going to confuse which one which, right? So you have to using self.Celsius, which means you're going to instantiate your structure later and got this object .Celsius, which is internally. Okay, this one always represent internal Celsius, right? And this one out right-hand side is always outside Celsius. All right, so so this is a for the self use. Okay, variable property. Okay, and I think we talked again, right? This is variable. Okay, we are going to use structure car, variable make, year, color, store. You are going to use a variable var, mean you can change it. Okay, you can change it. So we are going to have a car, make a Honda year 2010, color blue, start speed 120. You instantiate your first car, right? And then you copy to the second car. You see first car, a second car equal first car, right? You copy it, and then you're going to change the maker from Honda to Ford. You change this maker, so that's why you need to use a variable, right? If you're using let maker string, and then you cannot change here. Okay, you cannot change anymore. Okay, you're going to copy it. You always have to stick with Honda. Okay, that's why you have to use a variable here. Okay, variable here. Right, and also you are going to have okay, here we go. We actually using the variable second car here. Your object is a variable. Okay, let's say the second car here, you're not going to use a variable. You're going to use let first car. Okay. So you let first car equal car Honda 2010 blue 120, and then you want to change the color of this first car, and you're going to get error because you said let first car. This is your first car, which is a constant. You cannot change, right? So this is where normally, okay, we are going to using both. Okay, your property is a variable, and also your object is also a variable. All right, so this is for the structure. Okay, structure. Okay, now class. Okay. And of course, the first question is what is the difference between class and structure, right? It looks like for the definition. Okay, here's a class definition here. It's very, very similar like a structure. Let's say class person, okay, name, okay, and then initialize this object, okay, class, right? And also you can have a function call like a say hello. Very, very similar. It looks like it just change the structure to class. Okay, change the structure to class. Now, several big difference here. Okay, in this case, okay, this document said if you're using a class, you can inherit it. Okay, you can have a base class. You can inherit it from your parent class to the child class. But for the structure, you cannot do that. This is one thing. Okay, another big thing. Okay, class actually is so-called reference type. Okay, and structure called a value type. Okay, now let me talk about this one first. Okay, remember we have a structure. Okay, you are going to have a size here, right? And instantiate a sum size, and then you copy, sign this sum size to another size. This one the copy. Okay, this is a typical we call the value type. When you assign the value type value from one to another, they actually make a copy in the memory. You assign them all, they're gonna copy them all. Right? But for the reference type, okay, let me doing the class. I think we have also example later. Okay, let's do this one first. Okay, person here. Oh, it's a little different. Let me change this guy to person. Oh, there's a 2-person here. Okay, let me do this. Okay, let's coming back here. So let's say I have a class called size. Yeah, I'm going to copy this part of the code totally. Right, so I'm going to get class, okay, size, right? So this one basically is originally is a structure size, right? And I'm going to get a class size. Oh, sorry, I cannot do that. Okay, let's say size 1. Size 1 here, right? I give it a name here, size 1. It's a class now. Okay, everything I got a 1, right? And 1 here. Okay, now looks like I have a class called size 1. Okay, for this class also I have a width and height, right? I also can calculate the area. So I'm going to instantiate this object 1, size 1 with 250,000. Okay, and then I'm going to assign some size 1 to another size 1. Be careful here, since class is a reference type, so you are going to instantiate your first object in the memory. So you can remember, okay, in one place, normally called a heap, and in that memory place, you have a size 1 object, okay, and the width has 250 and 1,000. Now, when you actually assign this object, okay, some size 1 to another size 1, when you sign it on it, they are not going to copy because this is a class. They actually say this another size is going to point to this object. So for the class, we call the reference type, they are not going to copy. So this object this pointer actually points to the same object in the memory. So inside of the memory, you only have one place hold this 250 and 1,000. Okay, so now there's two objects, okay, point, some size 1 and another size 1. These 2 points point to this object in the memory. You only have 1 copy. For the structure, you have 2 copies this assignment. But for the class, you only have 1 copy. Now, what happens if you change this width, okay, into 500? Okay, you have 1 point to this place, change 250 to 500. Another one actually they're going to point to the same place, and then you're going to answer is going to still have a 500 because this guy changed its value and this guy pointed to the same place. They are going to get the same value. Okay, they're going to get the same value. Let me see. Okay, if I can run it. Accessible, what did that say? I may not get this one. Hold on. Okay, initializer here. Okay, let me do this one. I want to do this one. Okay, this example. Because that ini, we don't have ini, but for this class, you have to use the ini function here. Okay, so let's see. Person here, I'm copy this one. that size do not have a ini for the class, you have to use ini function here. Let me do this. Okay, I'm going to copy. Okay, so let's do it again. Okay, so I have a person class in this case. Okay, and this person class actually have a two property, name and age. Okay, I have a any function. Okay, you have to input your name and age. Okay, to instantiate your object person. Right. In this case, we are going to instantiate Jack, which is years old, 24 years old. Right. And then I'm going to Jack signed to a my friend. You see here? Okay, so this is Jack. Point to this person. When you instantiate inside of the memory, you are going to put an object in the memory. Inside of that object is a Jack and age 24. And then you're going to assign this Jack to my friend variable. This assignment for the class is not copy. It's a point to the same object. So in the memory, you only have one object over there. So Jack and my friend both point to this object, right? And then I go to Jack pointer to say age. So you're going to point to this age and plus 1. So this 24 is becoming 25, right? And then when you print out Jack's age and my friend age, since my friend is pointed to the same object, it's going to say get the same age, 25, right? So if you run this guy, you're going to get 225. All right. So let's do another one, okay, which actually change everything the same, but don't have identifier. Okay, they don't have identifier here. So let's say I'm going to copy this guy. Oh, I can do that. Make things interesting. I just copy the code. Okay. Copy here, right? It's more convincing if I do that here and change class to structure, and I don't have any here because structure you only need to get person, name, age, right? And assign here, check same thing, add should be same thing, right? Okay, so let's see what is the difference here. It should be Jack, same. My friend assigned Jack equal Jack age. Only these two variables. Oh, using variable. Do I have to use a variable? Let's run it. Okay, so we are going to have here. Now the key difference here is when you do the structure, this person here, right? You instantiate this Jack object here, right? And then you assign Jack to my friend. Now, since this is so-called value type for the structure, they actually make a copy. Okay, so Jack is an object in the memory. My friend is another object, totally different object, right? And then you're going to add a Jack age equal plus 1. So Jack becomes 25, but my friend is still 24. Okay, you're going to print out, right? Let me see if I can get it. Invalid. Okay, that's why you cannot use let because you have to use a variable structure here because you can make a copy read. Oh, okay, you're going to use the same name. I'm sorry. So this one inside of this one, you cannot do this one here. You have a person here, right? So you have to change this one to person 1. And person 1. Okay. Doing that. This one should be okay. Let's run it. Gosh. Have the same check. Okay. You have a check 1. My friend 1. Check 1. Check 1. Yeah, you cannot do the same variable in all of these definitions here. Check 1, my friend 1. Okay, so you're gonna get, okay, you see here, 24, 25. Okay, the key part here is when you do the class, you signed one object to another. Both these two actually is a pointer to this object. In the memory, you only have one copy. Okay, everybody point that. When you change the ones, another one actually is going to change because you're going to point to the same place, right? So you're going to point to the age, add 24 to 25. So everybody just see 25 now. For the structure, the key point here is for the structure here, when you instantiate object, this is one object in the memory, and then when you sign it, actually they make a copy. Okay, from original place, copy to another place, and this is my friend one place, and the Jack is the original one, and two copy. Now you're going to change one copy value here, okay, from 25 4 to 25, but the another copy is not going to change. Okay, it's not going to change. So this is you got a 24 and a 25. Okay, the new one, okay, the Jackie one is going to change to 25, and then my friend is still 24. Question?
Yeah. So in the class, can you make it so you could change it or no?
In the class?
Yeah, not the structure. Yeah. In the class, there's no way to get around that to, change it.
No, this is a typical way to doing it. This is a way to do it, right? Because this is Jack. Okay, only one object. You're supposed to do it. Okay, you say Jack.
The way you would get around this would be to have the person class have a clone method that instantiates a new person object, gives it all writes to that person object the identical properties, and then returns a new separate person object that my friend could then equal.
You can copy the class object.
Yeah.
Okay, you can copy a clone. You can call clone or clone, but it's not wrong, right? Let's say this is Jack. Okay, this is Jack actually in the memory. Okay, it's better because Jack this year is 24. Jack next year is 25, right? So there is a program, okay, or some kind of calendar to say after when he get his birthday, his age automatically increase to 1. Okay, so this is only one copy in the memory. So everybody, okay, as long as you point to the Jack, he's becoming 25. That's correct, right? I don't want to say the same Jack, okay, and this one program say he's 24 years old. The other program say he's 25. It's not good, okay? Actually, this is better way to doing this kind of things, right? But for the structure, okay, makes this wrong because you have to copy Jack, okay, and of course this one is going to be make it confused. Some programs say he's 24, sometimes 25. But now this kind of copy, there's also advantage. I don't want this object becoming Jack. Okay, this is Jack 1. When assigned to my friend, it's becoming John. Okay, so I can change the name, change the age for another object. This is a copy of the object, right? So if you wanted to do this kind of make a copy, you made a change for the name, also for the age, both are changed. So it's totally becoming a different object, right? So there's a
one is for inheritance while the other is just for copying.
Yes. So you just remember, okay, structure is a value type. You're gonna sign it, you make a copy, okay, and the class is a reference type, and they're gonna point to the same only one object, pointed to the one object. And if you one change, everybody change. Okay, so this is a typical so-called value type and reference type. And our book has another comparison, say when you are going to using class, when you are going to using the structure. And our class here is going to say class actually has a very good one called inheritance. Okay, so now this is very useful. Okay, let's go back talk about Apple. I mean the iOS development. You are going to use Swift, right? And actually, Apple is going to develop tons of the libraries. right? Let's say you have a button, you have a text box, you have all kind of object. I mean the UI object already developed. Okay, you only need to inherit. Okay, that's the whole idea for the object-oriented, right? Lots of the previous developed or companies, they develop lots of object. It's already there. You don't have to develop from scratch from the very beginning, right? You can just inherit one object from one originally developed class and add more, add new things you want to add it. This is great things for the object already called inheritance, right? Inheritance. So your program can improve, and you don't have to got from very beginning. And there's tons of company out there. What they do, okay, they just build some kind of class, either inherit from other one, or they build from scratch and then let other people inherit, right? So this is a typical inheritance. Go ahead.
Speaking of properties of classes and also the, hey, what if I want to do pass by value, but it's a class? Apple has what's called a protocol, which I believe is like an interface, except you can have more than one of them going on at the same time. Which I just linked in the chat. I'm not 100% sure on what a protocol is in Swift yet, but if a class is part of this protocol, then it already has a copy method. And if you want your class to have a copy method, you should implement this protocol.
Yeah, we're going to talk protocol later. Okay, we actually have a concept for the protocol, which is like a function point or something like that. Yeah, we'll talk this later. You're right. You're right. You can copy your class, okay, or cron or something like that. Definitely, the function you can do that. All right, nice. Okay, let me finish this one. Okay, so we had inheritance for the class, so the structure don't have. Okay, another thing is because of the class is a reference type and the structure is a value type. Normally, for the reference type means you don't have many copies, right? So it's going to be efficiently used in the memory. Let's say I have a class, which is a big one. Okay, I don't want it. Which big means it's occupied lots of memories, and it's going to need lots of CPU time to calculate for it, right? I don't want to have lots of copies flying around in my memory because my memory is very precious. Okay, so basically, class normally, if your object is huge, okay, or very complicated, you want to use in class. Okay, I don't want using structure because structure keep copying, right? So if your object is big, normally using class. Okay, if your object is relatively small, okay, and you are going to using structure. Structure normally is going to put in your memory called a stack. Class always put in memory called a heap. Okay, stack is very close to CPU and very fast doing it, but also it's precious. Okay, it's more expensive. So normally, if your object is smaller, you want to dealing with this kind of object quickly. Okay, you're going to use structure. Okay, if your class or your object is very large, okay, and you don't need that fast to dealing with it. Okay, you're going to put in the class. Okay, majority one in the class. Okay, but if you want to use it faster, okay, stack and a heap, that's another topic. But normally for the stack, it's very quick. Okay, stack means it's a memory size very close to CPU. Normally I can represent like when you do the stack memory, it's like you bring something in your pocket. So if you want to grab this one immediately from your pocket, it's very fast, right? And if it's a class, normally put in a heap. It's relatively far away. Okay, you can think, oh, I have a storage in Manhattan. Okay, and if you want to grab something from your heap, you have to drive to the Manhattan and bring back. But if you want your stack, it's like in your pocket. You can get immediately. But your stack is very small, right? You cannot put everything inside of your pocket. Right, so if it's a smaller, you want to fast access, normally using your structure. you can grab it from your pocket very quickly. Okay, if it's a big, and you can put it in your Manhattan storage room or storage building, and but sometimes if you access it, relatively slow. Okay, you have to do far away. Okay, because from your memory point of view, nowadays the computer memory is bigger and bigger. Okay, so sometimes you get something from a memory, it's taking much longer time, relatively speaking, right? And but if it's a stack, it's very fast. Okay, so it's like got a thing from your pocket. So these are the two differences, and I don't think I have time to do the class. Basically, lots of class concept is very like a structure, and let me see. Okay, if we don't, yeah, let me see. I'm going to decide the next class. I may need a little more time to talk about some kind of topics and about this class concept. But anyway, okay, you guys already read it, and hopefully this week you're going to do the question and answer and familiar more, okay, about this structured class concept. Any more questions in the comment? All right, and if not, is anybody I talked to, you can stay in the room? I mean, is it Brandon? Yeah. Let's do this. If you want to stay and talk to me about your homework or anything you want to talk, you can stay in the room, right? Otherwise, I just stop here for today's class. And also, I want to mention, okay, we had, yeah, some people not coming, or some people have the problem with one. If you want to, not want to, you have to talk to me on next office hour for last 2 weeks assignment and homework. All right, and yeah, I'm gonna send out email later. Okay, later. And the two things: one is what is the next week's assignment, and also, okay, and for the people who didn't finish the last 2 weeks, we have to talk in the office hour next Monday. Okay.